Hey, this is Matt Hines with DevOps TV for DevOps.com here at the Does 16 conference. We're joined by Julia Wester
Hi.
from LeanKit. Thanks for joining us. As I understand, you're here at the conference talking about predictability and magic and predictability, or
Yeah, how you have to be a wizard. No, it's so the whole premise was that we all want to be predictable, but I believe that people oftentimes really don't think that it's ever going to happen for them because they feel like so many things happen to them that are out of their control that predictability is not guaranteed or even possible. So I wanted to bring a little Don Reinertson and queuing theory to the masses and help people understand some of the choices that they can make about managing their work or managing their queues that can really make them either much less or much more predictable. So that's what we did today.
so I guess that begs the question, how does an organization begin to bring some predictability to this unpredictable world of DevOps?
Yeah, and the good thing is that you don't have to be a statistician or really even understand all of the math in queuing theory to have a positive effect on that predictability. I talked about 3 choices today, and there are many, many more, but I just picked 3. One is deciding whether to have a push system or a pull system, and basically how you queue up work for people to get done. And we talked about that from the angle of what happens if a person or a server in queuing terms gets blocked. If you've already queued up all of the work, then that just sits there and waits for them, like your supermarket when the cashier's red light goes on, and you hate that because you're in line. So that was one concept. And then the other choice we talked about was, how do we prioritize work? And again, we're talking about all of these things based on how much variation in cycle times are we actually introducing into our system. So obviously the ideal is just to process them in the order that they come in, because when we prioritize things, we're artificially deflating sometimes for some cards or work and inflating for others. But we did also talk about how that's not always feasible, and there are other considerations to be made when we decide which work to do first. It's just an understanding of the impact of the choices we make and questioning the assumptions that we make that do cut away from some of our predictability so that we know when we do it, it's worth the cost of that. And then the third choice is an old favorite from DevOps about batch size, right? Small batches versus large batches. And we know a lot of things about why it's better to have small, but how does it affect your predictability? And again, as things sit there being queued up, ready to be released for a large, say, monthly batch, we're artificially inflating the time all of those things are taking to get delivered, and it's introducing wider variations, and we're less predictable. And so smaller batches help us reduce the amount of artificial wait time we add to our system and help us be more predictable in our delivery. So those were the choices that we talked about today. But there's a lot more. If people saw Dominica de Grandis's talk on time thieves, you could see some other things that we could decide, like how we avoid or encourage dependencies, and many, many other things that can impact our predictability.
Yeah, the mind boggles. We can take the conversation in a lot of different directions.
Yeah.
I guess, you talk about 3 different approaches. How does an organization understand? It would be too limited to say which one is right for them, right? It's more about which one to apply in which, in various types of scenarios.
Right, and unfortunately, they don't have to choose between one of those choices. They can actually build on those. So, for instance, push or pull system, that can be an initial choice. And then once you've decided, say you want to go with a pull system because that leads towards less backlash when a person gets blocked, right? So then we can decide, okay, in our pull system, how do we want to order the work that we have in our queue, right? And so then we can talk about, well, we do it FIFO, or we do it prioritization based, or we do it around robin. All of these things will impact, the processing time for the individual thing being the same across the board. What are the other things that we're making decisions about that introduce extra weight into our system? So it's all about managing the weight there. And then, once we've determined our pull or push and our prioritization, then we can decide, are we going to do large batches or small batches? And so each of these choices can have a compounding impact on our ability to be predictable. So we might decide one is worth the cost, but if we do all three, we could really be making it bad for ourselves if one of our goals is to be predictable, which isn't always the case.
Right. From the sounds of it, again, I would guess it's a lot about flexible predictability.
Yeah, I mean, you do have to balance it. No business out there says their end business goal is predictable delivery. It's usually economics or, predictability is just one factor. So that's why it might be reasonable to make a choice that diminishes our predictability if the value of that choice is bigger in another area that's also important to us. Another concept we talked about is that predictability isn't always the fastest. Predictability and fastest are not the same meaning. Predictability is all about consistency. And so Don Reinertson, in his book, there's a tiny footnote where he uses the metaphor of the tortoise and the hare, the Aesop fable, and how the hare was really great at quickly delivering business value, but he lost the race due to long periods of inactivity because he would sprint and nap and sprint and nap. And so he might have been the fastest, but he couldn't be consistently fast, and he couldn't beat the tortoise who was slower but consistent. So that's another thing I want people to realize is that when they say they want to be predictable, they may be thinking predictable and fast, but that's not necessarily communicated out and may not translate to the people who are going to provide that predictability. Sometimes when you're going from delivering things between 2 and 200 days and you're not very predictable, to get more predictable, the bottom may have to come up as well as the top coming down. So like 25 to 50 days. So predictability and fastness aren't always exactly the same.
Right. It's less about speed.
Right. It's more about expectations and consistency.
Resourcing.
Yeah.
Right. What are we going to have available? Right?
Exactly.
And how we can accommodate that.
And that's actually how queuing theory was born. So back in the early 1900s, Erlang, mathematician at the Copenhagen Telephone Company, had to help solve a problem of how many telephone lines should they have so that no calls would be blocked. And just like us, they had random arrivals of incoming stuff and random durations that those things would take. And so they had to pull those answers out of the randomness. And they had to figure out what capacity they needed. And they determined that as you increase your capacity utilization, you have more and more things backing up. So queue size has a direct correlation to that. And if you want to be able to handle anything that comes in, you have to have excess capacity. So you'll never be always available if everything is at 100% capacity.
Right.
So, that's sort of how queuing theory was born, to solve that problem at the telephone company.
And it's
really cool.
Has some interesting things like cloud services were actually born as well, right?
Yeah, totally. There's a whole lot. I gave a talk at DevOps Days, Portland, I think it was. And I like to say that ops people know a lot more about processing work than they think they do, because they're dealing with all of these systems like operating systems that really understand scheduling algorithms, and they deal with networking devices that have queuing theory baked into them, and they understand some of these underlying principles. And so one of the things that we need to do is help them extrapolate that information and apply it to their work and how they manage their work where it makes sense to do that. So knowing that people know more than they think they do should hopefully be an empowering thought to them, that they can tame some of that chaos that feels inflicted upon them.
I'm not sure. I might know less than I think I do.
Maybe.
I'm pretty sure of
I
that,
guess
in fact.
that's a possibility.
Yeah.
I think on the bright side.
Learned quite a bit here. No,
Yeah.
it's interesting. And, we'll be looking forward to hearing in subsequent conferences and years how this continues to get applied, right? It's very, very cool stuff.
Yeah. Thank you so much for having me and letting me talk with you guys about this.
Thank you for joining us, Julia Wester with LeanKit. I'm Matt Hines with DevOps TV for DevOps.com at the Does 16 conference. Thanks again for joining us.